The first step is risk management, is to start with some data. In particular, you will want the return of the portfolio whose risk you are studying. This can be a portfolio of stocks or a combination of stocks and bonds. As an example, this course will assume that you are working with a portfolio of U.S. stocks. So we will need some return on U.S. stocks. One very useful source of publicly available data is the database maintained by the Federal Reserve Bank of St. Louis. FRED is the name of the database. FRED has many different kinds of data. There are macroeconomic data such as GDP growth, unemployment rates, money supply. There are also lots of financial data, including exchange rates, interest rates, commodity prices, and stock market indices. In this course, we're going to use some of the data from FRED. As I was saying, we will assume that we want to understand the risk of a portfolio of stocks, so we will need the return of stocks. FRED contains a few stock indices. We will use the Wilshire 5000 Total Market Return Index. This index represents a portfolio that invests in every single stock that trades in the U.S. equity market. The portfolio is valuated, which means that the portfolio holds the amount of each stock in proportion to their market capitalization. You can download the data by going to the website given on this slide. But it is easier to use R to retrieve the data directly. Here are a few lines of R commands to do this. Before I start, let me just say that the white box is just like the console in RStudio. R commands are in blue, and what R returns is in black. Let me go through these 5 lines of R commands very briefly. The first line loads the quantmod package using the library command. As a reminder, you will need to install the quantmod package before you can load it using the library command. The second line retrieves the data using the getSymbols function in the quantmod package. The getSymbols function can retrieve data from FRED and also from Yahoo Finance and a few other data sources. I will not go through all the details of the getSymbols function. At a minimum, you will need to provide the name and the source of the data series you want. In this case, we want the WIL 5000 IND series from the FRED database. We will put the data into an R object called Wilsh. One thing I need to tell you is that we have asked for a daily series. FRED gives you data for each day of the week. If there is no data for a given day, for example, it is a holiday, FRED returns NA for not available. We need to remove the NAs from the data. So the third line uses the na.omit function to delete all dates with NAs. A second thing I have to tell you is that when the data come back from FRED, you get all the data from the first available date until the latest date available. In the case of the Wilshire Index, it will start in 1970. But it only has data at the end of each month for the first 10 years. The daily data starts at the end of 1979. In risk management, we are interested in short-term movements of our portfolio, so we want daily returns. The fourth line keeps only the data from the end of 1979 to the end of 2017. Now, in real-life application, we will want to use all the available data. The reason we stop at the end of 2017 is this. FRED updates the database each day. So if we use all available data, then the result will change over time. This is the reason for stopping at the end of 2017, so you can reproduce these results on your own. In the fifth line, we will give the name TR to our data. TR stands for total return because this Wilshire index includes price appreciation as well as dividends from holding the stocks. It is always good practice to display some of the data just to make sure it is what we want. We can use the hedge function to display the first 3 lines in Wilsh. We can see that the total return index has a value of 1.90 on December 31st, 1979, 1.86 on January 2nd, 1980, and 1.88 on January the 4th, 1980. Note that the level of the index does not mean anything. It is the change of the index value that is informative. When the index value went from 1.90 on December 31st, 1979 to 1.86 on January 2nd to 1980, it is saying that the value of all stocks in the US fell during these 2-day period. We will use these index values to calculate returns in just a few minutes. We can use the tail function in R to display the last 3 lines of data. It tells us the index value was 123.67 on December 29, 2017. What this tells us is that the value of stocks in the US increased by more than 65 times from the end of 1979 to the end of 2017, assuming that all dividends are reinvested in US stocks. Of course, this increase did not happen in a straight line. The plot of the data using a logarithmic scale shows many ups and downs along the way. The goal of financial risk management is to understand the magnitudes of these movements, particularly on the downside. Now you're going to do a short exercise to practice getting data from Fred.